All right, it's your old pal, Mr. Cook, and we're finishing up the Unit 7 test review. So we just have a couple more problems to work on. We made our way through 7.1, 7.2, 7.3, and 7.4. Now it's the last stuff, the 7.5 stuff, the piecewise functions. So piecewise functions are pretty easy to graph out and use. You just need to know how to read them. That's it. This stuff tells you domain restrictions. So in other words, the stuff that you can plug in for the x value for each of these equations. Because what it does is it takes a piece of one equation and a piece of another equation, and it tells you specifically which x values you can plug into the whole thing. When we graph it out, it's pretty easy to graph. You just need to pay attention to like the domain restrictions themselves, because usually we'll use linear equations, so just like straight line graphs, and those are pretty easy to graph out for you. You just need to know the slope-intercept form of it. So anyways, with the domain restrictions, this tells us that these piecewise functions are split up at the line at when x is equal to 1. So what we do first, this is my recommendation to you, is to draw a vertical line for x equals 1. So you go on your x-axis, find 1, and then draw a vertical line right through there, a little dotted line, straight through there. This is kind of like our little barrier, and it's what separates one function from the other. So this function that we have here, negative 2x minus 1, is going to be used for x values that are less than or equal to 1. So that tells me that the x values that I'm going to use are all the ones that are less than 1. So which numbers are less than 1? Are they going to be the x values over here or the x values over here? So think about it for a second. If your x values are on this line right here, past this little vertical line that we have here, then it's going to be the x values 0 and negative 1 and negative 2, negative 3, negative 4, negative 5, negative 6, and so on. Those are all the numbers that are less than 1. So that means that this graph is going to be graphed over to the left of that line. So let's go ahead and graph it out. It's pretty easy to do that. You should remember how to do this from I bet, your pre-algebra class, not even your algebra class. So this one starts at negative 1. That's the one they're graphing out first, so it starts at negative 1. And then the slope tells you that it's negative 2, so it's going to go down 2 over 1, down 2 over 1, down 2 over 1. And then in the opposite direction, it's going to go up 2, left 1 each time. So up 2, left 1, up 2, left 1, and so on. So remember that our graph is going to be on the left-hand side of this little line right here, this barrier. So all the points that I graphed over here, I can get rid of. And there's even one point that's on the line itself. And since I have this equal sign here, it tells me, that little equal sign, that little line right there, tells me, and let me erase this just so you can see it a little bit more clearly. But since I have a less than or equal to symbol there, since that equal to sign's there, it means that it's going to include that point. So I can just keep that as a coordinate point right there. So if I graph in the rest of these points over here, pointing over to the left, one part of my piecewise function looks like this. That's it. That's half of it so far. That's one piece of the graph. Now we're going to graph the other piece. So the other piece starts at 2. So we start at 2 right here. And then it gives us a slope of 1. So that means that the graph goes up 1 over 1, up 1 over 1, up 1 over 1 each time to get to the next point. All right, so we're going to be graphing this one to the right of the dotted line because this graph is only going to be used for x values greater than 1. So what are the x values bigger than 1? That's going to be like 2 and 3 and 4 and 5 and 6 and 7 and 8. So all these points over here. It's important to note that this does not have an equal sign on it. So where the point is on the dotted line, that's going to become an open point, okay? So it's going to be a point that does not exist on the line. And all the stuff that's to the left of that line I can erase. So the rest of my graph actually only looks like this. And I'm all done. So this is my piecewise function. It's part of this graph and part of this graph, just pieced together, like glued together, if you will. And that's it. That's it for number 21. That's how we graph them out. So if I'm coming up with like steps to do all this stuff, the very first thing I did was look at the domain restrictions. And with the domain restrictions, I looked at the numbers that I had over here to make my vertical line. That's where it separates everything. Then I look at the inequalities, and that tells me where the graph is going to take place. So if it's the x value is less than 1, that's to the left of 1. So this graph is always to the left of this dotted line and nothing to the right of it. And then this graph, this line is a piece of the graph that's going to be to the right of it because all the x values that are bigger than 1. And if I put it together, it just looks like this, and I'm all done. Now we move on to the last problem of the packet, and that's going to be number 22, the word problem. So, you can expect a word problem about this difficulty. I don't think this is particularly difficult. All you got to do is just read it carefully, okay? And it's a pretty good application problem as well because it has to do with like how much pay that you get and all that stuff. So you have a job as a salesman, and your pay is $500 a month plus monthly commissions. So you automatically get $500 a month. On top of that, you get commissions. What commissions are? They are amounts that you get, amount of money that you get for how much you sell. So like if I was selling like calculators, okay, or something. If I sold you this calculator, I would earn back an amount of money that I get from selling this. So if this calculator is like $100 and I had like a 5% commission on it, then I would get $5 back because that's 5% of $100. If this calculator cost $20 and I sold it to you, I would get back 5% of that $20 that I just got from you for selling the calculator. So that's how commissions work. And it's important to note that as well when we go through these problems, just in case you didn't know what that meant. Okay, so it pays $500 a month plus monthly commissions on the dollar amount that of the product that you sell. So the first $25,000 that you sell, you earn 5% commission. For all sales between $25,001 and $100,000 in sales, you earn 8% commission. And for any sales over $100,000, you earn 10% commission. So we have to put together a piecewise function that represents pay based on sales. And I'm not 100% sure if this is something that we test you guys on, putting the equation together. But let's go through the process anyways, just so you can see what it looks like. So the pay function, P of x, is equal to, and then we put in these like little curly brackets here because we're going to put together 3 equations because we have 3 different domain restrictions. So when x is, in other words, the amount of money that we sell is up to $25,000, we get 5% commission back on top of the $500 that we initially had. So that means that we get in between, x is going to be between $0, so if you don't make any sales, and $25,000. And it's including that amount as well. Because it says, first $25,000, so including that. And if I sell in that ballpark right there, in between $0 and $25,000, then I get back 5% commission. So I get the $500 per month, and I also get 5%, so 0.05 of however much I sell, so times x. And that's how that equation would represent itself. The next domain that I have starts at $25,001, and it's between that amount and $100,000. So $100,000. 6 zeros, there we go. And if I sell in between those 2 amounts of money during the month, then I earn back an 8% commission. So it's going to look real similar to the first problem that we put together, the first equation, but it's going to be 8% instead of 5%. All right, and then the third one that I have is any amount over $100,000. So if x is greater than $100,000 and strictly greater than, you don't have to include that amount because it's included over here. So if that's the case, then I get the $500, and then I also get 10% commission of whatever I sell. So that's 0.10 times x. So this is our piecewise function. These are the domain restrictions that I have, and that's the equation that I have for it. So that's part A. And like I said, I'm not 100% sure, but I don't think that this is something that we would necessarily test you guys on. Just be aware that that's how you put together a piecewise function. So it says in March that you sold $19,000. So what was your pay for March? So the way that you do that is this is the amount that you sold and find out where it fits in these different regions. 19,000 is between 0 and 25,000. So that means that the amount that you sold goes into this equation to figure out how much you earn for that month. So it's going to be $500 for the month plus 0.05 times that $19,000 that you have. So that's all just calculator work at that point. Let's see what we get. So it's going to be 500 plus 0.05 times 19,000. and you get $1,450. All right, so that's for April. Looks for March. Now for April, it looks like you sold quite a bit more, $50,000. So $50,000 is between $25,000 and $25,001 and $100,000. So it's between these two. So we use this equation instead. So it's going to be 500 plus 0.08 times 50,000. And if we use that in our calculator, what do we get? So 500 plus 0.08 times 50,000. So $4,500. That's how much you earned in the month of April. So get your graph that shows your pay when you sell between $0 and $150,000 in sales. So this one's a little bit more in depth. Obviously, this would be something that would be like a mega points problem, probably like beyond the scope of the stuff that we do in a test. I'd probably think that this one would not be part of the regular test. Like I haven't looked at the test, but just based off of the severity of the difficulty of this problem and this one, these probably wouldn't be parts of the test. Like this one would probably be given or something. I don't know if the graph would even be in there, but I don't know. Let's graph it anyways, just because it's fun. So we need to space this out so that it goes in, up to $25,000 and then up to $100,000 and beyond. So like my x values would be scaled kind of weird. Let's see how many data points that I have here is for the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if I want to get beyond 100,000, gosh, I'd probably say that each of these would be, it'd have to be more than 100,000. So maybe like 120,000. Yeah, so what would 120,000? 120,000 divided by 20 be? So each one of these is worth 6,000. I guess that'll have to do. So 6,000, 12,000, and then 18,000, and then 24,000. So I'm just adding 6,000 each time. 30,000, 36,000, 42,000, 48,000, 54,000, 60,000, 66,000, 72,000, 78,000, 84,000, 90,000, 96,000, 102,000, yeah, 102,000, one more zero, and then 108,000, 14,000. 114,000, there we go, and then 120,000. Man, I was really slowing down there. Okay, so those are all my x values. Now let's find what the potential y values could be. Well, we know that I have one coordinate over here, 19,000 and then 1,450, and then it looks like at 4,500 for 50,000. Let's see what happens when I get 120,000. That would be over here. So let's see what that maximum value would be. 500 plus 0.1 times 120,000. So $12,500. Man, that'd be a lot of money per month. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, geez, let's see here. Let's make each of them worth, I guess, 1,200. I don't know. Yeah, because then that would be at 12,000. So that'd be pretty close. All right, so 1,200, 2,400, 3,600, 4,800. And then that'd be 6,000, 7,200, and then 8,400, 9,600, and then another 12 would be 1,0800, and then 12,000. Okay. Now it's like I guess get some points. So if you don't make any sales, you get automatically $500. That'd probably be like somewhere over here. And then what were some other values that we had? We had at 19,000, it's 1,450. So 19,000 would be like right here. 1,450 would be like, I don't know, like right there or something. And then we had another one that at 50,000. So 50,000 would be like right here. You get 4,500. So that'd be like right there-ish. And then, I don't know, let's plug in some of the end values. So at 25,000, let's plug in that for this equation. So we get 500 and then plus 0.05 times 25,000. And you get 1,700. So at 25,000, you get 1,750. So let's graph that point out. So at 25,000, which would be like right over here, a little bit past there, you'd get 1,750. So that'd be like somewhere right over there probably. Okay, so this is the first part of the piecewise function that I get. Then $1 over that. So let's just plug in 25,000 and see what we get. So 25,000 plugged in there, 500 plus 0.08 times 25,001, and we get 2,508 cents. So when we're at 25,000, essentially, it gets up to 2,500. So that bumps it up over here, like right there at that point. Oops, let me scroll that up a little bit. It'd be like right there relative to the graph. And then let's plug in our other endpoint, 100,000, into this equation. So we get 500 plus 0.08 times 100,000. 1, 2, 3, 4, 5, 6, there's 6 zeros, and that's $8,500. So when I get $100,000 worth of merchandise sold, it's going to be pretty close to about 8,500. So 8,500 would be a little bit over there, so like right there. And that matches up pretty well with our line that we have going here. There we go. And then after $100,000, it's going to be 10% commission. So let's plug in $100,000 and then find a couple values outside of that. So if I plug in $100,000 for that, 500 plus 0.10 times 100,000, and that's 10,500. So at 100,000, which is pretty close to here, I should get 10,500. So that'd be like right over here, just under that line. So like right there. And let's plug in 120,000 as well. 500 plus, and I know we already found this one, times 120,000, you get 12,500. So at the very end here, it'd be a little bit off the chart there. So there's our last little graph, and it'll just keep going up from there. Man, oh man, that's a crazy one. Yeah, this one would probably be like, you know, not part of the test, I'm guessing. Just know how to like plug values in when you have your piecewise functions, and that should be better. I think that a better problem to work on would be like, let's see here, let's look at the 7.5 stuff. Like this one, you know, like number 7 in the homework. Because this one's just sort of like, you know, what would the cost be of making 300 copies? So like, you know, plug in 300. Where does it go in the graph, you know, on your piecewise function here? 300 is in between these two numbers, so you just plug in 300 to this equation. Know how to do stuff like that, and you'll be all right on the test, okay? Like how to answer questions given a function. And, you know, if you need additional help, like obviously check out the 7.5 worksheets. That's it for this video. If you need some help, contact your teacher, and good luck on your test.